the adjacency matrix from a branch assignment table. With a list of branches indexed by numbers or letters and a list of nodes, I show the adjacency matrix using letters for nodes and the branch assignment table with numbers for branches and letters for nodes. So the list of branches are also called edges, and nodes are also called junctions or vertices. For an electrical network that's common in general physics, here are 6 branches that may be resistors, capacitors, constant voltage sources, what have you, and interconnect wire that joins them together. With an electrical circuit, you often will see the branches and the connection wire, but not necessarily the nodes. So here I'm using ovals to represent those nodes. And I've left nodes unshaded when a node joins together exactly 2 branches. For example, node A joins together branch 1 and 6. But I've shaded in nodes like C and D when, for example, C joins together more than 2 branches. In the case of C, branches 2, 3, 4, and 5. Now in the branch assignment table, we would use 1s to show a connection. So for example, branch 4 connects to C and D, so branch 4, row 4 in the branch assignment table shows 1s in columns C and D. But the adjacency matrix shows the number of branches that connect between nodes. So for example, node B can get to node C by a single branch, 2. So row B, column C, or row C, column B, there is some symmetry there, has a 1, right? And notice from C there are 3 branches, 3, 4, and 5, that can reach then node D. So row C and column D, or row D and column C have a 3. Here in Excel, here's my branches and here's my nodes, and there's a little index number. I can go from 1 to 2 and change to edges and vertices instead of branches and nodes. With edges and vertices, we tend to use letters for the edges and numbers for the vertices. But with branches and nodes, which is more common notation in physics class, we tend to use numbers for the branches and letters for the nodes. So here's the circuit, and again the identification of nodes, and let me just make them the ovals like we had before, and entry into the branch assignment table. And the goal is to determine from this branch assignment table through some calculations the adjacency matrix. For the purpose of calculation, each node will be assigned a prime number. 2, 3, 5, 7. If we had more nodes, we would keep going. So using the prime numbers, I can look at the branch assignment table and basically, if I see a 1, replace with the prime number for that node. Otherwise, just show a 1. And we'll paste that through a 6x4 array. So now the product of each row of numbers I've generated will produce a number that is the product of 2 primes that uniquely identifies the 2 nodes in the branch assignment. Or instead of prime numbers, if I use essentially like base 2 numbers, 1, 2, 4, 8, 16, 32, we can do something that's similar to file permissions in Linux. That is to have a sum of numbers where each number, if in the branch assignment there's a 1, replace the 1 with the node's number. And then again, just take sums of the rows of numbers, and you get a number that uniquely identifies the nodes in the branch assignments. I'm going back to primes, and I just want to show how to do a condensed version of what we did earlier. So this product function here essentially does all the work that we did before. We have the product of rows of information that look up the prime number based on there being a 1 in the branch assignment table. And then that product function is entered as an array, and it's filled down. And so that's just a more condensed way of doing what we did earlier. So for each row in the branch assignment table, I have a number that's the product of 2 primes representing the 2 nodes. So wherever I have a 1 in the branch assignment, if I divide that prime product number by the given node number, I'm getting the other node. So I have essentially a copy of the branch assignment table, but using the prime numbers instead of simply 1s for a branch assignment showing a node connection. Instead of the 1, I'm showing the other node that's connected. So for each column in our modified branch assignment table, I would just count the nodes based on rows in the adjacency matrix. So each entry in the adjacency matrix is a count based on the node number in the row of the adjacency matrix, the count coming from a column in the adjusted branch assignment table. And there we have it. We have the adjacency matrix from the branch assignment table.